Welcome to lecture 3. This is a new topic on photogrammetry. In this lecture, we will learn the basic definition of the photogrammetry, what it does, little bit of background, historical background of the photogrammetry, and the different types of photographs which we are using in the photogrammetry. So let's begin. This word photogrammetry is a Greek word. It is basically the combination of the word photo, which means light, gramma means to draw, and metron means to measure. So anything with the help of the light, if we take some measurements, draw them and carry out the measurement from them, that is called photogrammetry in fact. In photogrammetry, we are carrying out the measurement of the distance, area and elevations, and also the geometrical shape and size of the different objects. So this is all we are going to do with the help of the aerial photographs, and light is the sunlight is the main source to capture these photographs. So if we have to define the photogrammetry, it is a very simple definition of photogrammetry, the art and science and technique of obtaining information about the physical object on the earth's surface, and subsequently then use these photographs to carry out the measurement. So you can see in the diagram also the aircraft is mounting the aerial camera, and it is looking downward and taking the images of the object, and on the right side we can see the aerial photograph. So actually we have to take the measurements on these aerial photographs in photogrammetry. Photogrammetry is an engineering discipline, and today the photogrammetry is entirely different what we used to do earlier. It is quite dependent on the software and the hardware aspect in order to collect the data, in order to analyze the data. The increasing use of computer and software has a great impact also, which has changed our approach from using analog photogrammetry to analytical and then digital methods in photogrammetry. So from paper maps we have moved to the digital maps in the digital environment. Photogrammetry would require a certain skills, and that is why we are learning this subject. We have to understand the techniques, we have to understand how to make the judgments about the objects, about the targets which we see on the photograph, and subsequently carry out the measurements. So when we carry out the measurements, we carry out in 2-dimensional space those measurements, as well as we carry out the measurements in the 3-dimensional space. What the photogrammetry can do? We are using many times the single vertical aerial photo, but many times in large number of projects we may require third dimension. So we are using stereo aerial photographs. So when we are using mono photographs, we can carry out like distance measurement, we can find out the length between the 2 points, we can get the area, we can prepare the maps of the object. So we are dealing with the planimetry mostly when we are using single photographs, individual photographs. When we are using stereoscopic aerial photograph, that means the 2 photographs with overlap region, then we can determine actually the planimetry as well as the height of the object. So third dimension is measured with the help of the stereo images. So we can create 3D model, and the best example of creating 3D model is the digital elevation model, which we are using in large number of projects. Now we carry out measurement in the 2D environment from individual photographs, but when we have a stereo models, stereo photographs, we can carry out the measurements in the 3D environment. So our aim is that we get correct measurements, very accurate measurements, and the latest data from these photographs. In order to do that, we have to obtain the photographs which are highly accurate and which are latest. So we have to see that our photographs are highly accurate, they depict the highest quality, and they are latest so that we can get the latest information. This diagram is showing that how a 3D image. So, 3D image is imaged with the help of a camera, photographic camera, and we are taking actually the two images of this from two different angles and carry out 3D modeling. So, 3D to 2D and then to 3D in our computer environment, or the determination of the coordinates of the various points in terms of x, y and z. But we can do the reverse process also. If we have a two-dimensional photograph of the same object, we recreate the same geometry as it was while taking these photographs. So, the middle step what you see here is recreating the geometry in the laboratory with the help of the devices, with the help of the software, and those 2D images are converted into a 3D image. So, we can create a 3D model back in the laboratory. So, it is a reverse process basically which we are doing in photogrammetry. Let us go back a little bit and see the origin of the photogrammetry. According to the literature, in 1839 the first photograph was taken. It was a very big kind of a camera, and there was a spool of film which was loaded onto it to expose it. But when we are talking of the aerial photography, in 1858 Gaspar Felix, we is known as the Nadar also, photographed outside Paris in a village in France from a hot air balloon. So, this hot air balloon, which we see that it is used for many other activities, recreational activities, the sports activity, long back it was used to take the images, the photographs of the area. So, there was a basket, as you can see here at the bottom of this big balloon, hot air balloon, and the photograph was taken with the help of the camera. The axis of the photograph was also tilted because it was difficult, because of the stability of the balloon, it was difficult to keep the camera axis vertical. Now, this is a sample of the photograph which was taken outside Paris by Nadar in 1858. This is a landmark in aerial photogrammetry, and since the camera was not, axis was not vertical, it was inclined. So, one can even see the height of these buildings also from this photograph. So, you can have a perspective view and can estimate the height of the building, and the buildings which are closer, probably we can see the number of floors. So, this was very useful actually to get the information right in the laboratory from these photographs. So, mapping was done with the help of these photographs. Later on in 1860, James Black photographed Boston Harbor from a tethered balloon, and this was the photograph which was quite popular, and people appreciated this kind of a photography which was used for gathering the information from the space. Kites have also been used. The researchers have explored the various means to capture the data from the space. So, in 1882 the English meteorologist E.D. Archibald was among the first to take the successful photographs from the kites. So, there were small cameras which are fitted into the kite, and the kite was flown into the air, and the camera took the images. So, in 1889 Arthur Batut also took the photographs in the France area using the kite as a platform and mounting those cameras. Later on, rockets were used, rocket mounted cameras. So, when the rocket was launched, the camera was mounted in the rocket. As you can see, in 1987 the first successful aerial photograph was taken from a rocket mounted camera by the Swedish scientist Alfred Nobel, and today he is best known nowadays for the Nobel Prize also. His Nobel Prize is based on his name, after his name. So, this was a very good invention, that even the rocket can go up in the air and they can go quite up and take very large view of the terrain, and we can use these photographs. Some scientists have explored in 1903, like Julius Neuberner designed and mounted a tiny camera for carrier pigeons. So pigeons were used. We have seen in the movies the pigeons were carrying the message from one place to another. So the pigeons were used actually to take the images of the ground, and very tiny camera in the breast of the pigeon was fitted, and when the pigeon was flying, taking the images, and pigeons, those are very homely. They come back to the same place where they have started their journey, and then those photographs can be used to carry out the mapping. But it became much more popular during the World War period, which was 1914 to 1918, and this was the era when the aerial photogrammetry has developed. In fact, the photographs which were taken from the aircraft, they were used for battle purpose. So for army purpose they were primarily used, but later on, after the World War, this technology got the further impetus to use in the civilian area also. So these aerial photogrammetry was used for civilian purpose, for mapping the landscape, mapping the various features and carrying out the measurements from these photographs. In the meantime, when this photogrammetry was used in war and then later on civilian purpose, various kinds of aircrafts were developed. So there were many companies, many organizations came forward to develop the aerial platforms, aircrafts, because we need specialized aircrafts for this purpose, not the normal one, and we need a specialized person. As you can see, there is an operator, so we need a specialized operator who can operate the camera which is mounted in the aircraft. So a lot of companies came forward. So if we look at the technological development in the photogrammetry, how this photogrammetry have developed over a period of time. So this was earlier a simple photography taking with the normal camera, and then graphical photographs came. Then the aeroplane was used as a base platform to capture the images. Later on in 1941 the use of computer came, and we switched over from manual method to analog photogrammetric method, where we could create a 3D model from the stereo images, but still the plotting, the preparing the maps was manual, and then afterwards the analytical photogrammetric methods came, where the instruments were fitted with the computers, and there were digital plotters to plot the maps, and then later on the digital photogrammetry, workstation based. So in the workstation you have the software, and then high-end workstation can perform all the actions from 1988 onwards. So we have moved actually from manual photogrammetry, analog photogrammetry, to complete the digital photogrammetry aspects. Different cameras have also come up in the market, looking into the demand. So we need a imaging device, we need a camera which could be mounted on the aircraft to take the images of the area. So these cameras were mounted, and they are looking downward most of the time when they were mounted on the aircraft and taking the images. But also there is one branch of photogrammetry which is called terrestrial photogrammetry, where the camera was mounted on a tripod. So we are closer to the object and camera is mounted on the tripod. So the camera was used in two different ways, but the aerial cameras were different and the terrestrial cameras were different. So various models of cameras actually came for, and you can see the conventional aerial cameras. They were very bulky and large format image, the films were required, and the big spool of films were loaded, as you can see in the cross section of the camera. and they were very big, very bulky, heavy, and you have to carry the sufficient amount of film uh, up in the air when you are taking the images, because if you have shortage of film you cannot come back to the base station to collect the film only. Then from conventional camera, today we have come to the age where we have a digital aerial cameras, where there is no film inside and you have the CCD devices, and then you can take the images in more than one spectral wavelength region. They are very compact, they are very lightweight and easy to operate. So these digital cameras are available with different makes and different or firms, and they are used nowadays in digital photogrammetry. If we look back the products, what kind of products we are getting from this digital photogrammetry? Well, large number of products we are getting, we can derive also the secondary products from the primary products, but earlier we were getting the contact prints. So this was the actually photogrammetry when we were using analog, we were using film. So film was exposed and the contact prints were made later on in the laboratory. The standard size was 9" by 9" or 23 centimeter by 23 centimeter. So this was the standard size of the contact print or the hard copy photographs. When the analytical photogrammetry, when the analog instruments came, then we require the film positive and diapositives. So film positives and diapositives were created from the film negative later on, so that we can use them on the instruments and carry out a 3D modeling and carry out the measurements or mapping work. The stereo photos, these photographs had the overlap, successive photographs had the overlap, and the overlap region was used to create a stereo model. So they were taken in the stereo modes. Then the later on the digital photos came. So it's no more hard copy product, it was all in soft copy environment and directly usable in the computer environment. So there is no need to expose the film, making the film, sometimes when you are doing that process you find either your prints are overexposed or underexposed, but in digital photos that limitation is not there. If the photograph is dark or photograph is too bright, I think you have digital image processing methods, software available to enhance the image or to correct the image. Then in the laboratory, enlargements were made. Sometimes the contact prints were not good enough actually to carry out the measurement, to carry out the mapping, to identify the objects. Then enlargements were made at different scales so that the mapping is done accurately, so that identification of the object is done accurately. These enlargements were done in the form of a paper print or projected on the projection plane on a big table or the wall, and the maps were prepared by putting up the piece of tracing paper on the enlargements. Well, the photographs are not used in isolation, so mosaic was another product which was created in the lab. Mosaic is basically joining the several photographs together with the help of the overlap region, so that we can see the bird's eye view of the whole area. One single photograph will not cover many times your entire study area. So you have to create the mosaic, join them together and see the bird's eye view of the area and use that mosaic actually to carry out the mapping work. And orthophotographs. Now because these photographs have distortions because of the perspective projection system which is used, so these we have actually the orthophotos where the property of this photo is similar to a map. So this work again is created in the lab. So there are many products which are primary products, there are other products which are secondary products. Now I like to tell you that there are basically broad two types of photographs available to us. One is the aerial, where the camera is mounted in the aircraft, and we are taking the images looking downward and taking the images of the ground with the help of that photogrammetric camera. So this is called the aerial images, aerial photographs. The second category in photogrammetry is the terrestrial photographs. When we are closer to the ground, we have set up our instrument tripod closer to the ground, and camera is actually facing the object. So in first case, the camera is looking downward, and in second case the camera is looking almost horizontal direction. And in terrestrial photogrammetry we are closer to the ground, so that we can get very detailed information. So development of the cracks, or maybe identification of the inclination, so things like that. When we have to do the minute study, we have to take close up of the object. So we are taking terrestrial photographs, and with the help of those terrestrial photographs we carry out the measurements. So if you look at this diagram, it further gives the classification. So we have the aerial photographs, we have the terrestrial photographs. Under aerial photographs we have further subdivisions. So the one is the vertical photograph, another is the oblique photograph. So as the name itself is suggesting, probably the camera axis is vertical in one case, the other case the camera axis is oblique, inclined with the vertical line. And under oblique, now there are two categories here, a low oblique photograph and the high oblique photograph. And under vertical we have two categories. One is truly vertical photograph, when the camera axis is exactly vertical, and another is the tilted photograph, when the camera axis is between 1 degree and 3 degree tilt with respect to the vertical line. So here this diagram on the right is showing when the camera axis is vertical, we get a kind of a square format covered on the ground. The area covered on the ground will be kind of a square format. A low oblique, when the camera axis is inclined, we can actually have more area covered at this end of the ground and lesser area covered on this end of the ground. In high oblique photograph, when the camera axis is further inclined, we can see the horizon, we can see the ground as well as we can see the horizon. So I think it will be more clear into the next slide. This is a vertical photograph. Here camera is looking downward, and this vertical photograph is quite useful to us in engineering mapping purpose. So this photograph camera is looking downward, and this is a 23 centimeter by 23 centimeter format. Then the second category here is the low oblique photograph. So this is low oblique photograph. The advantage of in this low oblique photograph is that you can see the height of the objects. So one can see the height of the object, and these photographs have been used to estimate the number of story in the house and the height of the structure also. But the scale is not uniform in this particular case. But the third category is the high oblique photograph. The high oblique photograph, the camera axis is further inclined with respect to the vertical, and you can cover a much larger area as compared to the vertical photographs. When you are looking vertically down, you are covering the smallest area, but when you are highly oblique, you are covering the large area. So here you can see the horizon also, skyline, as well as you can see some high-rise buildings and the land part. So again, here as far as the information is concerned, you can get large amount of information, but basically this cannot be used for topographical or thematic mapping purpose. Low oblique photograph and high oblique photographs are very useful for defense, for army purpose, and from engineering point of view we are using vertical photograph mostly. So there are different uses of vertical photograph. As you can see that it has a minimum distortion and can be used for taking the measurement. So most of the time for our engineering work we are using vertical photographs, so that we can carry out some kind of a thematic mapping or topographical mapping. Now the camera axis is mostly vertical, but up to 3° that can be accepted. So this is the use of the vertical photographs, whereas terrestrial photographs. In the terrestrial photographs, we are closer to the object, closer to the ground. So one can see the hill mass here, and the camera is at I1 position, then at I2 position, and then at I3 position. So from these 3 positions of the camera, we are taking the images, the facade of the object, and now we have 3 images. Probably there is some overlap also between these 3, so we can create a 3D model of the area. So what is the basic difference between this terrestrial photograph and aerial photograph? Aerial photograph, we get the plan of the object mostly when we are talking of the vertical photograph, and in terrestrial or close range photographs, what we are getting is the elevation of the object, the facade of the face of the structure, and we can carry out the measurements of that. So there are many studies where we require close range photogrammetry. You can see the output of these photographs like 3D model measurements or point coordinates. So these are the 2 positions of the camera from where this building face has been mapped. So we have 2 photographs and there is some overlap. So we can use also for creating a 3D, finding out the coordinates of the different points, and also the biggest use is for deformation study, deflection, monitoring of the structure, facade mapping. So these are the advantages of terrestrial mapping, where aerial photogrammetry cannot help us that much as compared to the terrestrial photograph. We can get very precise coordinate, we can monitor the area from a close distance. So for deflection or deformation of the damage study, these photographs are very, very useful to us. So this is all about this lecture. Thank you.